Hello, Physics Nation. My name is Nate Larmond. I'd like to do a Khan Academy problem from the set called Calculating Speed and Mass Using Conservation of Momentum. A firework initially at rest explodes into two pieces, one of which weighing 2 kilos, ay chihuahua, has a mass of 2 kilos, flies to the right at 15 meters per second. The other piece flies to the left at 20 meters per second. You know, even the pros get sloppy with language. It would weigh about 20 newtons. It has a mass of 2 kilos. That's okay. That's okay. I'll take it. So, as the title implies, momentum is conserved. If there is no external force, we usually say if no impulse acts on the system, there is no change in momentum. So, this exploding force, one fragment is going to go to the right. Oops. And one fragment is going to go to the left. If the exploding force is internal, pow, pow, then there's no change in momentum. Okay, so if the system starts with no momentum, it ends with no momentum. This is the puzzle my students get confused by. Well, momentum is a vector quantity, so the positive momentum from this guy is perfectly canceled by the negative momentum from this guy. All right, mass isn't a vector quantity, but velocity is. And so the product of a scalar and a vector is a vector. Momentum is a vector quantity. So really, it's just like you start with 0, you end with 0. 0 equals m1 v1 plus m2 v2. The sum of these two momenta is 0. So there are lots of different ways to express conservation of momentum. Here we have an exploding firecracker. Wow, 2 kilos. This would be a gigantic explosive if a fragment has a mass of 2 kilos. Anyway, this guy's going to the right, so 2 multiplied by 15 is 30 kilogram meters per second. And let me see, we want the mass of the other one. So we're looking for M2. And let's see, how would we do this algebra? Ooh, to the left. All right, so we would simply add negative m20 to both sides, and we would get m equals 30 divided by 20, which is 1.5 kilos. And that's going to get us the happy confetti. Let's see, 1.5 kilos. What? What am I doing wrong here? Hang on. 2 kilos flies to the right. That's the positive momentum. The mystery kilos flies to the left. What is the mass? Oh, before the explosion. See, I did my question, not their question. I found the mass of the mystery fragment, the one going to the left at 20 meters per second. They didn't want to know the mass of the other fragment. They wanted to know the total mass of the system. See, do their question, not your question. 1.5 plus 2 is 3.5 kilos. Making fun of Khan getting it wrong, and I can't even get it wrong. This is a shame. Hang on. 2 plus 1.5 is 3.5 kilos. Hey, better late than never. Thanks for watching. See you in the next video.